Welcome to The Explainer. Have you ever really stopped to wonder what's going on under the hood of AIs like ChatGPT or Gemini? Well, today, we're going to trace that exact journey, from a single spark of an idea to the massive AI brains that are, let's be honest, changing our world. Let's dive in.
You know that feeling, right? You type a question and a perfectly crafted answer comes back in seconds. It almost feels like magic, like you're talking to something that actually gets you. But here's the thing, it's not magic at all. It's the story of a truly brilliant idea that's been scaled and refined at a pace that is just breathtaking. And today, we're going to unpack exactly how it all works.
Okay, so first things first, what exactly is a large language model, or an LLM? Well, the simple definition is right here. It's an AI that's been trained on a massive amount of text data. And when I say massive, I mean truly massive. Think a huge chunk of the internet, books, articles, websites, you name it. All of that data teaches it to spot the patterns, the structure, and all the little subtleties of how we humans communicate.
So our story really kicks off in 2017. Before then, AI really struggled with language, especially with long sentences. But one single research paper, with the incredible title, "Attention is All You Need," introduced this revolutionary concept that just solved this huge problem and basically set the stage for everything that was to come.
So, before 2017, the models we had read sentences one word at a time, sequentially. The slide really nails the analogy. It was like trying to understand a story by looking at it through a tiny straw. By the time you got to the end of a long sentence, the model had already forgotten the beginning. But the transformer architecture, it changed the game completely and let the model see the entire sentence all at once, processing every word in parallel.
So, what's the secret sauce? What's the transformer superpower? It's a mechanism called self-attention. This is the core idea. It's what lets the model look at a whole sentence and intelligently figure out the importance of every single word in relation to every other word, no matter how far apart they are.
Okay, let's look at a classic example to see what I mean. In the sentence, the tiger jumped out of a tree to get a drink because it was thirsty. How does the AI know what it refers to? Well, self-attention is the answer. It lets the model look at the entire context and see, it is very strongly connected to the tiger and not the tree or the drink. Simple, but incredibly powerful.
So how does this actually work? You really don't need to be a math whiz to get the big picture. Basically, for every word, the model creates a few different representations. It then compares these representations across all the words in the sentence to calculate what are called attention scores. The important thing is, this creates a weighted map of connections, which reveals the true, deep contextual meaning of the entire sentence.
All right, so the transformer gave us that core brilliant idea, but an idea by itself isn't enough, right? The next chapter in our story is all about one thing: scale. It's about taking that concept and just supercharging it with unbelievable amounts of data and computing power, turning a clever idea into a genuinely powerful brain.
The years right after the transformer was invented, well, they were a frantic race to get bigger and bigger. OpenAI's GPT series is the perfect case study. GPT-1 proved the concept worked. Just a year later, GPT-2 was 10 times larger and started showing it could do things it wasn't even trained to do. And then in 2020, GPT-3 just exploded onto the scene, over 100 times larger than its predecessor.
GPT-3 was an absolute monster. We're talking 175 billion parameters. You can think of these parameters as all the little knobs and dials the model can tune while it's training to store information about language. For a couple of years, the thinking in the field was really simple. If you want a smarter AI, you just have to build a bigger one. But that whole bigger is better philosophy, it was about to hit a major plot twist. In 2022, researchers at DeepMind published this groundbreaking paper on a model they called Chinchilla. They went back and looked at the fundamental scaling laws, the recipe for building these things, and what they found changed the entire industry. It wasn't just about the size of the model. To get the most intelligent AI for your computing budget, you needed this careful balance between model size and the amount of training data. This chart from the paper, this was a bombshell for the entire industry. That dotted line, that's the old way of thinking. Just throw more parameters at the problem. But the solid lines show the new, optimal path. The huge discovery was that models like GPT-3 were actually undertrained. They were too big for the amount of data they'd been fed. It turned out, for the same amount of computer power, a smaller model trained on way more data would actually be smarter.
And the proof was in the pudding. The results were just undeniable. Chinchilla had only 70 billion parameters.
less than half of GPT-3. But it was trained on a mind-boggling 1.4 trillion tokens of text. That's 4 times as much data. This was a true paradigm shift. It meant you didn't need the absolute biggest, most expensive model to have the best one. Smarter training, not just bigger size, was the new name of the game.
Okay, so now we have this massive, powerful, data-optimized model. It's like a brilliant brain that has literally read the entire internet. But how do we take all that raw power and actually make it helpful, make it align with what we want, and, make it safe to use?
The answer is that we have to move from that brute force pre-training phase to a much more delicate process of fine-tuning. Think of it this way. Pre-training gives the model raw knowledge, like it's read a giant library. But fine-tuning is like sending it to finishing school. It's about teaching the model not just what language is, but how we actually want it to use that language to be helpful and harmless.
And the key technique to do this is called reinforcement learning from human feedback, or RLHF. It's a 3-step dance. Step 1. You start with some basic supervised fine-tuning. You just show the AI a bunch of high-quality examples of prompts and perfect answers written by humans. This gives it a good baseline. Step 2. You build a reward model. This is cool. You have the AI generate, say, 4 different answers to the same prompt. Then, you have humans rank those answers from best to worst. You use all that ranking data to train a separate AI to act as a judge, one that learns to predict what answers humans will like. And finally, step 3, you use that judge to train the main AI. The LLM generates answers, the reward model gives it a score, and through a whole lot of trial and error, the LLM learns to produce answers that get higher and higher scores, effectively tuning itself to be more helpful.
And that brings us right up to the cutting edge. This technology is moving so fast, evolving beyond just text and into new kinds of architectures that are way more efficient and way more capable. So let's take a quick look at where this is all heading right now.
A huge development is that models are becoming multimodal. What does that mean? It means they're not just trained on text anymore. They can natively understand and process images, audio, and even video, all within a single, seamless input. This lets them reason about the world in a way that is much, much closer to how we humans actually perceive it.
Now, to handle all this complexity more efficiently, we're seeing new architectures like this one, Mixture of Experts, or MOE. See, the old way was like having one single genius who had to answer every question about every topic. An MOE model is totally different. It's more like having a whole team of specialized experts, one for history, one for coding, one for poetry. Then you have a gating network that's like a receptionist. It looks at your question and routes it to the 2 or 3 best experts for that specific job. It's just a vastly more efficient way to build these things and lets them scale to incredible sizes.
And this table right here really just wraps up the whole journey perfectly. You can see the evolution so clearly, from that initial concept with GPT-1 to the obsession with massive scale in GPT-3, followed by that crucial insight about data from Chinchilla. And now we're in the era of natively multimodal models like Gemini. And just look at those numbers. The growth in both the model size and, even more importantly, the training data is just staggering.
So what's the big takeaway from all this? In less than a decade, we've gone from one clever idea about attention to these incredibly powerful systems that are starting to understand our world across text, images, and sound. The fundamental task has shifted from just predicting the next word to performing really complex reasoning. And that rapid, unbelievable progress leaves us with one final and really important question. As this technology learns to reason more and more like us, how will we choose to collaborate with it?